Right, great. So this is chapter 4. This is the first lecture from chapter 4, which is, in a way, I think I mentioned that chapter 2 and chapter 3 sort of are new chapters have come into the picture. But what we have is chapter 4, which really was chapter 2 because it carried on nicely with activity-based costing, which I mentioned at the end of chapter 2, towards the end of chapter 2, because we're discussing, if you remember, comparing traditional um, traditional methods of absorbing overheads to this new method, really, which is referred to as activity-based costing. But we'll come to that. But really, the argument here is really with the evolution of cost management, with the evolution of how of manufacturing. We're moving away from, if you like, labor to machinery to, if you like, automation. So we're moving into more refined ways of of measuring costs, of managing costs, and just of manufacturing in general. So, and I mean, in the US, this is of course very much in the US and Japan. There was this drive towards automation was very much something that was brought in to improve efficiency. And so cost efficiency was really the key driver here. So the really general central idea was if we could automate, we could be a bit more cost efficient, as you would imagine. So the principles really were really the ideas really here were about total quality management, having things just in time. So really, and a key problem for a long time has been this cost of holding inventory or keeping inventory and inventory going bad or not being useful anymore or for whatever reason. You might make all these things at the time they're worth something, and then suddenly some sort of shock comes along and they're no longer worth anything. So the argument really was, how do we arrive at a just-in-time sort of process where we're getting raw materials when we need them, and we're only really making goods to order, if you like, and this way we get our money in, but there's no point getting money in and having all this other inventory in the warehouse. So it's really about this sort of efficiency ultimately. So total quality management refers to this continuous improvement in quality, productivity, and effectiveness. So just constantly looking at the process, and we're going to see that as we carry on looking at this, just constantly looking at the process involved and seeing how we can improve that. Um, so looking for where the errors are, trying to prevent them, looking at the systems, looking at the products, ensuring that everyone is involved in the process and able to give their own views and to sort of highlight where the issues will be. Um, Strengthening relationships with suppliers, if you like. So because really what this allows us is, think of a scenario where your supplier can actually see your inventory and has access to that. So as your inventory is falling, they can see it falling and they can supply you in time. So really having systems that can satisfy this improves, if you like, a number of things. Just understanding that this is critical to what we're doing, continuous improvement. And again, like I say, JIT is just in time, is a pull through basis, which really responds to customer demand. So the customer wants it, and then we now order the raw materials, and the raw materials are on hand, as opposed to keeping large stock of material and finished goods, which are costs in themselves, if you like. Um, Remember this kind of this with the cost of holding inventory, things like that. And you might remember this from a long time ago. Right. Where are we? Yeah, so just in time, key characteristics for successfully operating a system like this. So you can see that we're getting close to this automation, high quality, computer aided manufacturing technology will assist, small batch sizes, um, rapid throughout to meet their customer needs. So pretty much quick and efficient systems. Right, and yeah, so I talk again about what standard costs are. I refer to those from our last chapter. Really, this you're producing in batches, you're producing a lot, so you have the same cost of making something. So we come to some kind of informed intelligent, budgeted view of what the costs of making this are. So, what are the key features? Like I highlight all this already. High levels of automation, typically high levels of overheads, but a different type of overheads, and not a lot of labor involved. So, we're moving towards, yes, manufacturing modern manufacturing. So typically we're customized products where we're trying to respond to the individual demand, if you like, of our customers, because where we realize that really to gain the entire surplus, we want to make sure we're being able to respond to the exact needs of each customer. We're not keeping a lot of stock, like I mentioned here, and high quality, continuous improvement. So what is ABC sort of arguing? ABC is sort of arguing that it can, if possible, a scenario where, and we'll see the example in a second, a scenario where we just had just this um, these big overheads, this total overhead. Remember, in the last chapter we had this overhead of 80 grand. The argument is we can actually see what's causing this. We can actually see what's driving this 80 grand, and there must be some cost drivers somewhere. So we're really saying the issue here, again, like all things, you can't measure what there is no process for. If you don't have a process for something, if you don't have steps in place, you can't know. If you just finally get a bill, you don't really know what's causing it. So there is a job in sort of knowing, in determining what's causing something, which is we refer to as the cost driver, and having a way of mapping exactly what those costs are, so you can actually then control them. So you can't control what you can't measure. And ultimately, we're arguing that what's causing these overheads is no longer labor, like we've talked about. There are other things, a range of other issues, and so that's why activity-based costing comes into play, if you like. Um, so we sort of move away from that traditional sort of thinking where the argument was that everything was caused by either labor or machinery, but now we're saying that no, there are other things, if you like, in play. Um, so here, where are we talking here? Yes, I'm just sort of looking back to the past and talking about how traditional costing was really the thing. Traditional absorption, very much labor intensive, if you like, and we came up with some kind of rough estimate. And you can see the issues here is that if we're not if if we're not talking about labor, if it's not volume driven, then how do we then decide on what's causing it? If we can actually clearly isolate what these overheads are, why not? If you like, why guesstimate? So we have different types of overheads now, which are a large proportion, and we don't want to make a mistake and um, randomly spread it using an inefficient base, if you like. So it's important to get an accurate estimate. And I talk about this idea of manufacturing, the nature of manufacturing changing, and we also have a real diversity and complexity of products. So we really need to make sure we get that right. So we can see a range of things here that actually examples of drivers of this um, of this new type of overhead. So this 80,000 now, where once upon a time it might just have been light and heat. No, you have quality inspections, you have setup costs, if you like, you have delivery costs, you have just the, if you like, packaging costs. But those are all driven, if you like, pretty much by not by light, water, or heat, but by really sometimes by volume, but just because of the way the setup of the process is going, if you like, handling purchase requisitions, things like that. So these are all the new types of, if you like, drivers of this overhead that we didn't see when we did traditional absorption costing. So someone sat down and actually counted the number of quality inspections that have been generated for the different products that have been made. So I highlight here again the traditional costing systems typically went with volume. But what we're saying here is, and what used to happen was traditional costing methods would tend, again, so low volume, what you would then get is a low overhead allocated to you. But that's not necessarily the case. I think in class I talked about the idea of having, imagine you have 1,000 paracetamol tablets here, and you have one really important vaccine tablet. You wouldn't say, that okay, we have an overheads of 80,000. You wouldn't split it based on the fact that there's so many more tablets here, so they should get more of the overhead, simply because we don't know how much really this overhead might be due to it's not due to light and heat now, this level of automation. The machines are doing everything, but you might have about maybe 7 quality inspections just to make sure that this one drug is fine, and one quality inspection because this is paracetamol, so this should be charged as 70,000 and this should get 10,000. So you can see the issue here, that we need to find a different base, and that base can no longer be labor hours, really. Okay, great. That's 10 minutes, so we'll carry on in part 2.